right, I think we're live now. Hello, everyone. Welcome to today's meetup. Hi, Nicholas. Thank you for being here.
Hello.
Today's topic will be low-code exploration and visualization of your data. And Nicholas is here to walk us through, I believe, around 60-minute presentation. And we'll take all of the questions at the end. So, Nicholas, please go ahead, introduce yourself, the topic. Yeah, take it away from here.
Thanks a lot. Hi, everybody. Thanks to be here. Thanks to give me your time. I am Nicolas Frankel. I've been a developer. That's my 2 decades now. And a couple of years ago, I also became a developer advocate. I was a consultant, and it was very frustrating because in a lot of cases, I had to find technical solution to organizational problems, and I wanted to do only tackle technical problems. So I became a developer advocate, and well, I hope you will like this presentation, which I hope is technical enough. At any point, if you've got any questions, please ask me. The thing is, talking online is not super great for you and not super great for me because there is no interaction. So if you've got any question at any point, please ask the question, and Dalia will interrupt me and say hello, and I will try to answer it. So the idea is we have data, and nowadays we have more and more data every day, and somehow we have too much data to understand. So the idea is somehow we must have a graphical visualization, some graphs, some bar charts, some maps, some whatever, so that it's easier, it's more digestible. And if you check data viz or data science or data anything, so this is in French, unfortunately, but you can see already that here the first stuff is this is French, but here this is Python. Python is ubiquitous. If you want to do data science, you must do Python. If you want to do data visualization, you must do Python. And you know this stuff like this meme, hey, use the best language for the task. And I believe this is that's a very big fallacy, because switching to a new language for a person is not trivial. First, you need to learn the syntax. And actually, in my 20 years ago, a few books were popular, hey, learn C in 3 weeks or learn Java in 2 weeks. And the syntax itself, if the syntax is close enough to a language you already know, from C++ to Java, yes, you can learn it in 2 weeks, even 1 week. The problem is not learning the syntax. So the problem is to write idiomatic code. So again, when I started working, it was at the time when people from C and C++ started to switch to Java, and you could recognize the code from somebody who knew C or C++ before. At the end of every method, they reset the variable to null because they were afraid they would create a memory leak. And they didn't know about, or perhaps they knew, but they just wanted to make sure not to create memory leak and just to tell the garbage collector, hey, this is okay. So it takes a long time to learn to code the idiomatic way of any language. Then once you arrive there, you probably want to use the libraries, because Python itself is not the best tool for data science. It's just that it happens to have all the libraries that you need. But then you need to learn the libraries, and perhaps in some ecosystem, like for Java, for example, you've got a couple of libraries just for logging, for dependency injection, and for everything. So you need to choose a stack. And depending on your context, a stack, some libraries might be better suited than others. And when you've chosen the libraries, then you need to know the tooling. I'm a Java developer. I know how to debug. I just run in my IDE, I set a breakpoint, and then presto, I've got everything. How does it work in Rust, for example, where it's a binary? Do you have the IDE for that? Well, do you need to learn a new IDE? So that's also complexity. And it's only for one single person, because afterwards there are this group sociology, and there must be change management. So if you are already good, skilled at a language stack, perhaps it's better to find perhaps a slightly less good library and use it because you already know all the rest. Again, this is another definition from Wikipedia. So we have data viz and data exploration. And when you want to make sense of your data, probably you have, like, you go from data viz to data exploration and data exploration back to data viz. And this is like a feedback cycle. And you go from one to the other. Once you understand more your data, perhaps you want to focus your visualization on something, and then you get back to exploring further. And I have a use case today to show you that. I want to explore the changes made on Wikipedia. So let's see how it works first. Here, I already have something working. So you go on this page, for example, and you've already a UI that allows you to stream the changes. So here, let's get some live updates. You can have like some filters, and then you receive, I can perhaps show the network tab. And here we can probably see, yes, the requests, they are made, and then it changes every now and then, and it refreshes, and it's good. But of course, here I'm limited by the UI, so I cannot do whatever I want. Perhaps I can get some interesting stuff, perhaps not, but I cannot have this feedback loop. Likewise, here I found another one, and here also I've got, at least I have JSON directly, but yeah, as you can see, I've reached the limit. So once I've got 100 events, I've reached the limit. I cannot do anything. The only thing that can I do is like trash everything and stream again. And as you see, it's very, very fast. So I arrive to the limit very, very fast. I will remove tabs because yesterday I had issues. So let's hope I won't have issue today. So UI is fine, but I missed something. So on the data viz part, I have Pibana. Pibana actually is a no-code or very low-code platform. It allows me to have a lot of widgets that I can explore my data on. The only thing that I need is how do I get the data. So there are a lot of solutions, but I work for a company called Hazelcast, so I will use Hazelcast for that. And actually Hazelcast, perhaps if you are Java developers or developers on the JVM, you already heard about it. Like in general, people know us because of our in-memory data grid. So that's one big part of Hazelcast. But actually, since version 5.0, we added another feature. Before it was called Jet, and now it's part of the platform. And actually, it's the stream processing engine, an in-memory distributed processing engine. So you have got like a couple of sources, and of course, if nothing suits your fancy, you've got here, you can create your own, which I will do in the demo. Then you can do the transformation, combination, enrichment, whatever. And then you can like sync it to any of the available syncs. And here you can see if something doesn't suit you, you can create your own. Here, I don't have Elasticsearch, but actually there is an Elasticsearch sync, so you don't need to write everything by yourself. So what I will be doing, I will be using Hazelcast. I will be just coding the pipeline and dumping everything into Elasticsearch. And then I will play with Elasticsearch to have this like exploration loop. I've talked a lot, and I will be trying not to be too long, just not like yesterday. So let's jump to the code already. So here I'm in IntelliJ. I've created a Java project. So I hope you are familiar with Java. If not, no worries. I've coded in Kotlin anyway, because I believe it's more intelligible. But there is no framework involved. What you just need to do is you need to create a pipeline. So you create a pipeline. And then on this pipeline, you read from a source, as I mentioned. Here, you add the timestamp. That's how you transform it to a streaming job. The difference between a stream and a batch is that the stream starts and never ends until you stop it explicitly, while a batch, when you've finished reading all the data, it stops. And then at first, I will write it to the std out, just so that it's intelligible. Here, I can create a Hazelcast instance. So we have two deployment models. The first one is embedded. That's what I will be using here. The other, once you start relying on Hazelcast, it's not for data exploration. It's basically you've got a cluster and then you send a job to it. Here, I will create the instance and like send the code directly inside. And here is the fun part, is how do you read from Wikipedia? So again, I'm using the Hazelcast API. Here, I'm creating a stream with a name and a context. The context should be immutable because the context can be like distributed among all the nodes. And here, the only thing what I'm doing is the context is reading from this URL. I'm using a library to read event streams from with OKHTTP. It's made by Launch directly. So here the context is I pass that and I start reading from the stream. Then I will every time, well, not I, but Jet will call that repeatedly. And what happens is I will read from the queue, because here I have a queue. And until this queue is empty or I have more than 100 elements, I will remove stuff from the queue and I will put that into a buffer. This buffer is provided by Jet itself, by Hazelcast. And then, oh, sorry. And then I will be able to get the data. It will be part of the pipeline. And as I mentioned, I will write it to the log. So let's see how it works. I will start the application. And now we've got our data. And it's a stream. So we can, well, I will stop it explicitly because otherwise it might take too long. And the idea is now I can get the data here. I will copy paste it into my text editor. I'm not a VI fan, I'm sorry. Then I can like format it. And here I can read some data already. So we can see that, for example, it's from a bot. We've got some comments. We've got the domain URI. We've got another comment, and so on and so forth. And we've got the user here. So if I do that repeatedly, I need to copy paste it, to format it, to make sense of the data. And again, if I have thousands or 10,000 of them, I won't be able to explore anything. So the first thing that I want to do is put the data into Elasticsearch. That's the second step of my Git. So I will give you the link to the Git repo. Everything is public, so don't worry if you are not following along. So here I have updated the pipeline. No, I'm not writing to the console out. I'm writing to Elasticsearch. So for that we have already a primitive. For that you just need to pass some, like here I made a client builder, so I can override it, and depending whether I'm using Docker or I'm using Kubernetes or I'm using Elastic Cloud, I can pass those environment variables and it will dump the stuff. So I've already prepared a Docker Compose. So I have already here a Pibana that is already loaded. Of course, everything is empty. I started from scratch. So if I go to Discover, it will tell me, hey, you've got no data. So now the idea is I will dump the data. When I write to Elasticsearch, I write not an index request. That's what I provide to the API, but actually it will use the bulk API so that every, I don't know, 10,000 or 1,000 or 200, it will send everything in bulk. So it's super fast. Let's try that. So now I'm using this local Docker compose, and we should already have something. So now if I come back here and I will close it, I will go to index pattern, and I will create an index pattern. Yes, I want to create an index pattern, Wikipedia, and I create the index pattern. And now everything that the schema has been inferred from the first requests, and we can go to discover, and we've got some data already, and we've got fields. So what is interesting to me, for example, is the meta URI. Something interesting also is, let's say, the user. And perhaps if it's a bot, I don't want to have bots. So I want to have bot false. Interesting, I still have bots. And here, anyway, in all cases, we can see that there are some users, and we have like IPv6 or IPv4 addresses. So that's interesting. So that's already something. And when you start realizing that, then you check on Wikipedia how it works. And I don't know, perhaps you're already aware of it, but there are two ways to contribute to Wikipedia. The first one, you create a dedicated user, then you're logged in and you can make changes. But to reduce the friction so that anybody can contribute to Wikipedia, even without creating any accounts, you can make anonymous contribution, but in that case, they log your IP. And perhaps I want to understand like where in the world are those changes like appearing. So I want perhaps to understand, to geolocate it. But first, if I refresh it, you can see that I've got no more data. What happened? Well, let's check our pipeline. Oh, I've got an error exception. That's very strange. Well, actually, that was expected. The problem here is that I've got these like log param fields that we can check how it looks like. Log param. Well, it's a nested field. So it's a big object, nesting object. And the problem is, sometimes it returns null. And what happens if you check further is that the provider, instead of sending you an empty object, it sends you an array, an empty array. And of course, an array is not an object. So Elasticsearch recognized log params as an object, and now it cannot do anything with it. So the first thing that we need to do before like exploring is to fix this issue. So you might have heard that the job of a data scientist is actually curating data 80-90% of the time. Well, we are doing the same here. So I will do the curation. And because of the pipeline, what I'm able to do is to have this like map primitive. So map is like from functional programming, or at least in Java, in Kotlin, in a lot of languages, it's called map. So you transform an object into another object. So here I've created like a dedicated class, which is very generic. You tell it the name of the field that you want, to transform. And actually, if you've got this field, if the JSON has this field name and it's an array, it will put instead a JSON object in, it will replace it with the JSON object. So now we can again start the pipeline. Something I did here also, I added a peak because I want to make sure that something is happening. And if something is not happening, I want to be sure, Is it Elasticsearch the issue, or is it in my pipeline? So here, as long as it's scrolling, I know that something is happening. Of course, in general, you don't want to do that. You might want, just because you've got a lot of data, you can sample it. So you can pass a function that say, for example, hey, I will take a random number from 1 to 50, and if it's 0, I will log it. So you've got a sample of one line every 15, well, randomly. Let's check again here. So I will refresh it. I will just wait a bit to make sure that we don't hit the issue, because here we've got like for 1.5 minutes. So you can see we already have more data. So perhaps it's random, and perhaps we were not lucky before, or perhaps we fixed the issue. So I believe here we have fixed the issue, and you can see it continues to read and to write. And it can continue for a long time, but at some point I've seen that the provider makes very strange data. So sometimes for a time it gives you a string. Anyway, for now, I believe that's for our exploration purpose, it's good enough. So I will stop it because it takes a lot of CPU. And well, let's continue doing that. Here I like I dislike the name clean code, but I like my code to be more readable at least. So what I can do, instead of mapping, which I believe not everybody is familiar with, I just want to make it like easier to read, so that instead of mapping and having an object that transforms, I will just change it, and you will see it's not a big change, but for me it makes a big change. Here, I have a function that transforms a JSON object into another JSON object. I can encapsulate it to here, change a stream stage into a stream stage. So here, if I like specify the type explicitly, is the stream stage of JSON object into another stream stage of JSON object. So I go one level above, and I will like change this function. And now I've got this like apply. And apply is very generic, because map or filter or whatever is very specific. And if you are not aware of it, you might miss some like information. But here, I believe this is important. Make field object if array. So you can probably disagree with the name, or perhaps you can find a better name, but the idea is here we can tell explicitly what happens. And as you can see, now I have a function that transforms a stream stage into another stream stage. So I'm not at the object level, I'm the stream stage level. Also, the benefit of this is here I can set a name to the stream stage. So when I start, I will stop it like very fast, because I just want you to show you the beginning. Yes, this. You can already see what happens. You can already see some of the names. So even if you are not the developer, you can already understand by the name what happens. Okay, that's good. Next one. Yeah, I wanted to geolocate. Finally, I can try to geolocate. There are several ways to geolocate. We have the IP. So you will find a lot of web services that allow you to geolocate. The thing is, we have a very fast data pipeline. And if every time we ask a web service to ask for geolocation, then it will slow down our pipeline, and it's not that interesting anymore. So I found an API that allows you to do that. So first, what you need to do is you download their database, and then afterwards you are able. Sorry, that's why I don't have it now. And afterwards, there is an API to query the database. So everything happens like on the nodes. I don't know why I have that now. So now we have this apply enrich with location. And here we don't have map, we don't have filter, we don't have anything. We just apply this transform, and this transform is enriched with location. And I believe it's like, it tells the intent. Again, we can set the name. And what I'm doing is I will like use the API, and if I find the city, so that means that first I need to check if this is a valid IP. So I'm using another library because I don't want to run into the exception problem. You might know that if you are on the JVM, the exception is quite time consuming, resource consuming. I want like to have like a fast pass. So first I make like normal validation with a normal library. And if it returns me a Boolean, and if it's a valid IP, then I will add some information about the city. So let's do that. I'm checking the time, so I don't take too much of your time. I will try to be less than 1 hour. I will try my best at least. So now I've got this. Let's get back to here. So now I have more data, and perhaps I want you have those new fields. So here I want to say location.city.name .en equals anything. So if it's not empty, hey, already? No. Perhaps I missed something. Let me check the data first. Or I was too fast. Okay. Available fields. Oh, hey, I've lost my fields. Yes, thanks. Location the names.en. So I will add it. Now I have location city.names. So it's names. Now I've got quite a few of them. Montreal, Munich, Shambara. So we can see already that what happens. But as I mentioned before, this is a lot of data. I cannot understand what happens with doing something right now. So I would probably want to do that on a map. Makes sense? And guess what? Pibana is made for that. So I go on like analytics and I go on maps. I have the world map and I have the layer. And I have the documents. So I select my index, and it tells me that my index pattern does not contain any geospatial field. Well, that's an issue. So far, I was very happy because Elasticsearch was able to infer the data type, and so far it was pretty good. But the problem is that it cannot infer geopoints. You must have an explicit mapping. And now I have a chicken and egg problem, because if I first create the index, it will infer the schema, and I won't be able to update it. But I must first have an index to tell about the schema or not. So I will scratch everything. I will scratch start from start. So stack management, index management, and I will delete the index. Perfect. And now what I will be doing, I will be creating an index pattern. And meanwhile, what I can do is I will update my codes to change the stuff a bit. So for now, what I did is I put everything into location, and I had names.de, names.fr, names. I don't care about that. I want my own data. So I can transform actually what this API gives me and only use, come back here, and only use, and it's here, sorry, what I want. So I will be using the ISO code of the country. I will be using the name of the country. I will be using the city, and more importantly, I will be using the coordinates. And coordinates are the longitude and the latitude, and this is actually what I want to use. And I will create the index template with that. So now I will create the index pattern. No, it's not the index pattern, it's the index. Let me check, index management, index template, sorry. So now I can create the index template. The first thing that I need to do is I need to tell it to give it a name. Then I will give it an index pattern. You can use star, but here I have only one, so that's not important. Here I click on next. Here I click on next. Here is the most important part. So I know that my field will be called like location.coordinates. So I've already written it here because I'm super lazy, and that prevents me from doing any mistakes. And it's not a text. I want it to be a type of geopoint. Update. Next, nothing. Next, nothing. Create templates. Manage, I don't need to do anything. That's perfect. Now I start my pipeline again, and I will get some data again. And it could be cool if it started. Please start. It should peak, so I don't know why it doesn't work. Let's see. Discover. Okay. Ah, finally. Refresh. No, because I didn't create. No, it's here. Okay. I was too fast. So now I'm on the same page, but now I can understand the more important stuff. So I've got the location country name, or let's say location city. And it's quite interesting, but now I'm able finally to go to the maps. So I can go on the map and I can do the same that I did before, but now it will be a geopoint, so it can be located. So I click on Wikipedia, and now you can see I've got this, and this allows me to go further. You can already see on the map. I will tell it that it's Wikipedia. And now what I want to do is when I click somewhere, I want to have some data points. So what I had before on my discover stuff, I want to edit now. So I add meta URI. I want to have, let's say, the comments and perhaps the city, although it's already available on the map. And also I want to have the city that is not empty. If the city is empty, I don't want to display it. So location city info. And here we already have something. That's good. So we have somebody in Dnipro doing something on Wikidata. And we have somebody in like Tokushima doing something on the Japanese Wikipedia. And here in Netherlands, it's good. So now I want to go a bit further. I want to understand who is doing what in which language from which location, because Wikipedia is like the sum of all knowledge of humanity, and so far it has pretty good quality, but you might have heard that there are some attacks by trolls who want to change. So the world right now is, well, perhaps it was also before, it is not super like stable, and perhaps you might have a group of hackers in one countries who want to attack another countries by changing their Wikipedia or doing some bad stuff like that. So I want to understand the language. So I can do that. I will add another step. So you can see that now it's still doing it. And now I've run into another issue. And now the issue is the following: log params count try to pass field count as objects. And again, it's another issue. So you can see that sometimes the provider doesn't provide always like consistent data format. So if you are not exploring but doing real data science, you must be sure that everything is very defensive. You must defend yourself all the time. So now I will try to infer the language type. Again, because I want to understand the comment from the comments what has been done. There are two ways to do that. The first way to do that is, again, I bring in a library which is called Lingua, and it detects the language. It gives me the best bets. And if I found a good bet, I can put the language as a nested object with like the ISO code into the ISO code in free and the name. But actually, sometimes it's not super great. It gives me not super great results. So I will skip you this step because if I don't have the right sample, it doesn't work that much. So what I want to do is to have a degree of confidence. So I go a bit further. And what I'm doing is when I detect the language, I don't detect a single language. I detect like as many languages as I can. And the library allows me to do it. It returns a map, a sorted map, with the first value as confidence 1, and it's the language that is the most confident. Then I will get the second one. And if there is no second one, that's perfectly fine. If there is a second one, I will get the second most likely confidence, and I will remove it, like I will subtract it to 1. Because the first one always has 1.0, and I want to understand the second one. So if this one is super, super close, then probably the algorithm like tried to make his best bet, but couldn't really be sure. I could here, and that's very important, I could try to filter it here. But since I want to do the data exploration, I will push as much data as possible in Elasticsearch, and I will adjust the filters on the Pibana side. So now if I run it, I will be able to filter it and say, hey, it must have a certain degree of confidence. And it should, so only one data point, that's not enough. So either my CPU is like very, very slow, which can be the case, or there is some other issue. In all cases, I can refresh. So normally now I should here have some data point, and I can like have a filter. So let's say that here I will have another filter. I will say, hey, sorry, not this one. My CPU is burning. Not this one. Okay, I think that I will stop the demo here. I will directly show you what I did before, because StreamYard plus Docker Compose plus everything is going to kill, well, is killing my computer. So I'm here, I did the same with like on Elastic Cloud. At least I didn't have Docker Compose to take care of. And this is what I can do. So I can edit it. I can edit the map. Edit here. And I don't want the last 15 minutes. I want the last week. Perfect. So now I have the language name, the confidence, and here I can have, so I want all data points that have a language name. So if there is no language at all, I'm not interested. And where the language confidence is higher than 0.2, but you can do it, you can do whatever you want. And it gives me interesting results. So here in Kazan, we can see that here, the comment was this one. Fortunately, I know some Russian, so I can tell you this is really Russian. And somebody from Kazan made a change on the Russian Wikipedia, which is like genuine. I don't know if I found any bad stuff. So here in India, somebody made a comment in English on the English Wikipedia. So yes, because Indian people, most of all, they know English. And then you can continue and check, have some data points. And well, you can continue doing that until you are happy with the result, until you found somebody who was not playing nice or whatever. And I am at the end of my presentation, which is good, 40 minutes. I was like quite fast. So I will just finish it. So thanks for your attention. You can read my blog. You can follow me on Twitter. If you're interested about the code, as I mentioned, like please check it on GitHub. It's this link. I have the stuff for that, but it doesn't work. No, it works. No, yes, it works. If I got you interested in Hazelcast, though the talk was not about Hazelcast proper, you can join our Slack or get some free training. And now, perhaps there are some questions.
Thank you very much, Nicholas. Right on time.
I try to be as fast as possible.
You're great. Thank you very much. Let's see if we have any questions. I don't see anything on the chat. Just someone, Dinesh, said thank you. So thank you again.
Thanks.
Let's see if something is going to come up.
If you are too shy, and I understand that, online is never a great way to ask questions, just ping me on Twitter. My DMs are open, or join the Slack and ask a question. Meanwhile, here you've got all the data points.
Awesome. Okay, well, I think we can wrap up early in that case.
I found some things weird. Look, in Portugal, we have a change in German from to the German Wikipedia. But it seems to be okay. It seems not to be bad.
Okay.
I don't think that anybody in Portugal is really interested to change the Wikipedia page for Trendelburg. That's not a really important Wikipedia page. Apart from the people from Trendelburg, but
yeah. Let's see. Oh, someone asked a question.
Oh.
Where can I find
here? Just go there. You just use this link. It's a bit.ly, so bit.ly hz Wikipedia, and you will find the code. It's not the script, it's the code. And it has all the steps that I've shown you, so you can do the steps one by one to really understand what happens. Other questions?
Jan was the only brave one. Let's see.
Thank you. You were brave. So I cannot give you stickers, but you seem to have a Dutch name. I will be in Amsterdam next week. So if you find me, and I will give you stickers.
Are you gonna present there, or?
Yeah. I will be going to JFO.
Nice. Cool. Good luck presenting there.
Thanks.
All right. Well, I don't see any other questions. We can wrap it up early. And thank you one more time for the great presentation.
Thanks a lot, folks. Have a good evening.
Bye. Have a good evening.
Bye. Bye.
Bye.